299,792,458 meters per second. The speed of light in a vacuum is the bedrock of modern physics. It dictates how fast information travels, how stars burn, and how the structure of the universe remains stable. But at the absolute smallest conceivable scales, physicists theorize that the smooth, continuous fabric of spacetime disappears. It is replaced by a turbulent quantum void. One model for this extreme scale is called kappa Minkowski spacetime. Here, the grid of reality becomes non-commutative, meaning the coordinates no longer line up evenly. The geometry of space warps into a jagged lattice. Theoretical breakthroughs have allowed us to model how localized light signals, like individual pulses, behave when traveling through this warped grid. The math reveals a massive anomaly. The speed of light stops being a constant and becomes dependent on an arbitrary parameter called alpha. In this model, the velocity of the light pulse fluctuates wildly. Theoretically, it could travel at any speed. If the most basic rule of physics is mathematically arbitrary at a quantum level, we face a contradiction. If light can travel at any speed, why does our macroscopic reality remain stable? Consider observers Alice and Bob, separated by a vast distance. Alice sends a light signal. Normally, there's a specific time delay, but if we adjust the alpha parameter, making light 100 times faster, the signal flashes across the gap almost instantly. If light travels nearly instantly, it shatters our understanding of cause and effect. The physical continuity of the universe relies on a strict speed limit to ensure events happen in a logical sequence. This creates an impossible reality where signals arrive before they should. To reconcile this model with the universe we actually observe, the math requires a compensatory mechanism. This reconciliation happens through a gauge transformation. It's a mathematical bridge mapping one realization of physics onto another, morphing smoothly between different states of reality. These transformations dictate that the universe compensates for changes in fundamental parameters to maintain physical equilibrium. The critical pivot in the math is that the transformation affecting the speed of light does not act on light in isolation. This chart shows the relationship between velocity and scale. As the speed of light increases by a factor of x, the physical distance bar rises in exact proportion. The transformation simultaneously rescales all distances in the universe by that same multiplier. In this quantum model, speed and spatial distance are perfectly linked. Changing one automatically triggers a change in the other. We can now return to Alice and Bob with this understanding of distance scaling. When the speed of the light signal becomes 100 times faster, the celestial bodies are pushed outward. Alice and Bob are now 100 times further apart than they were before. Because the distance increased at the same rate as the speed, the total travel time for the signal remains exactly the same. Bob detects the pulse at the precise moment he originally expected it. This is because our standard unit of length, the meter, is defined by how far light travels in a fraction of a second. The speed of light is the ruler we use to measure the universe. Any mathematical change to light speed is instantly absorbed into a redefinition of the meter itself. The ratio between the two remains locked. The ambiguity of light speed is a mathematical illusion. Because the universe scales distances to match, our physical measurements remain perfectly consistent. Even when the smooth geometry of space breaks down at the quantum scale, a hidden symmetry ensures the universe remains consistent. If you have thoughts on this quantum scaling paradox, let us know in the comments. Be sure to like and subscribe for more deep dives into theoretical physics. If you enjoyed this video, please give a like and subscribe. Today's video was brought to you by Synestex Systems LLC and founder Shane Kersinger. Synestex supports the exploration of the complex mathematical structures that define our reality. Thanks for watching.